So for the first one, you get 20 squared, 20 squared, then you have 18 squared plus 18 squared, and you wind up with 400 is less than 648, which means it's a cube. Nope, can't do that with exponents.
No, the side squared plus the side squared.
I'm just saying, like, if you want to say like 18, so we have to do over those.
Yes, sir.
Yeah, because 18 squared plus 18 squared is 36.
No. No, if it was 18 squared times 18 squared, then it would be the fourth power. But when you're adding, you have to do them separately. Next one, you get 3.25 squared, 1.25 squared, and a 3 squared. These wind up being equal, so that one was a right triangle. And then the last one, you got 12 squared, 3 squared, and 100 or 10 squared, excuse me. So you have 144 is greater than 109, so it was obtuse. Okay. Very, very, very easy setup problems. These are the types that are pretty quick. Just got to remember how they work. Okay. Next grouping is when you have, when it says use the special triangles to solve. This is where you would use your 30, 60, 90s, or if you had to fall back on trig, you could fall back upon trig, it would have been just fine. When we're dealing with the fallback on trig, excuse me. Remember, we always have SOHCAHTOA. I have not. I know that it has happened. They do clean up, and it just makes it real sticky on there.
You guys, the formula page in your review packet is the old formula page. You will have the other helpful things, right?
No.
They will not.
What's on here is what's going to be on here. Yep.
So not this updated one that you guys did?
Nope. It's going to be this.
So what is this updated one for?
This is what I use for that one formula, so they're not going to do this or this.
Okay.
Everything else. Because Pythagorean theorem, they've had it since 6th, 7th grade. And SOHCAHTOA
is SOHCAHTOA.
Right.
So write that on your
Absolutely, man. So, I mean, if you think about it, the only other things that you don't really have on that formula sheet is SOHCAHTOA and special right triangles. Right, I mean, because you can use SOHCAHTOA for it. So, if you write down SOHCAHTOA on your sheet, that formula sheet that you have, and you write down, a squared plus b squared equals c squared, by all means, that's fine. That's actually smart testing because that way you know that you're remembering it to go right into the test. You guys, like we've done before, you can write all over the test. There's going to be parts that are going to be just the answer on. The other part will be where you just fill in you just hand in the short response stuff. So that's not going to be a big deal. Now, as we're getting into these, let's see. Oops, I'm on the right page. Oh, right, close. So in this one here, is it a 30, 60, 90, or a 45, 45, 90? And why is that? Because there's a 45. The pattern goes x, x, x root 2. And if you were talking to somebody before, they did 1, 1, root 2, 1, root 2. Same thing. Now, we know across from the 90 is equal to 10, which means we have our little algebra jig now to solve for x. Divide by root 2. Your calculators will do that. So you're going to get x is going to equal 5 root 2. Which means everywhere else I see an x, what do I put? 5 root 2. Okay. Now, let's say you forgot specials. If you forgot specials, you're going to fall back in SOHCAHTOA. You circle your angle. That's your what? Opposite. 10 is your? Try again. It's hypotenuse. What trig functions is opposite hypotenuse? Sine. So the sine of 45 is x over 10, which means that was the one scenario when you had the unknown in the numerator. What you do with the denominator? Multiply on the other side, you get 10 sine 45. And it's going to give you same. Now, I know yours is going to give you a decimal, so you're going to have to make sure that sometimes when you have that multiple choice stuff, you might just have to go through and figure out which one's correct. Right? If it's doing it
Would
that
you
way.
be able to type in our calculator by square root to enter and we'll give it no?
Those calculators only do decimals. It does not do simplified. I know, right? $135 calculator won't do what a $15 one will. All right.
But it's expensive, so
Next one, we've got a 3060. So when you have 30, 60, 90, you've got your x root 3, and the 2x. In this case, we know again across from the 90. So your 2x value is equal to 100, means x is 50. So across from the 30 is 50. And then the other side, 50 root 3. Same deal. What trig function would you have used to figure out across from the 30? It would have been sine again. You know, the opposite.
we use signs.
You have it's the opposite. You have to get the hypotenuse and the hypotenuse. Number 8, you got to do a little bit extra math. Nope, they're not. That's why they're written like that, so that way you make that mistake. You know what I mean? Because you'd go back, oh, what if we done for over? So here again, you got 30, 60, 90. Across from what angle do you know? Well, we know across from the 90, so this has to equal 24 root 3. Divide both sides by 2, and you get 12 root 3. Now, that means everywhere I see a value of x in my algebra jig, I'm going to put 12 root 3. So in the calculator, all I have to do is 12 root 3 times the square root of 3. And you're going to get 36. Okay. If you're not using that, again, this one you have sine. It's convenient. It just seems like everything winds up being sine today. Number 9 is different than number 6, even though they have 45s and 10s. And number 9, you know, across from the 45 is 10, which means across from the other 45 is 10, which means across from the 90 would be 10 root 2. Real quick.
They're not throwing something.
So in this problem here, this is when you have them mixed together. You got a 30, 60, 90 next to a 45, 45, 90. Now this is the one where using your special right triangles makes it so much quicker than trying to do trig. In the 30, 60, 90, you know across from which angle?
The 90.
90. Which means everywhere I see an x, I'm going to replace it with 8. So across from the 30 is 8. Across from the 60 is 8 root 3. So I start filling that in. 8 root 3. Which means over here, these are my 45s now. So 45, 45, 90. It is so much faster to use your specials as opposed to trig. A lot less mathing. Yes, sir. Now we get into the using all the trig stuff to find your angles and whatnot. It could be either. We mixed it up. I think it's a pretty fair mix between multiple choice and the free response for the styles of questions. It's a pretty even mix. True, but remember, if you start thinking about it, you're either going to be right or wrong, aren't you? And if you've got 40 multiple choice questions, you're going to be right or wrong at least 40 times. You start multiplying that out with a 25% chance of being correct every time. Nope. Remember, the probability of getting a B was what? 0.00. It was like 12 zeros and a 4.
Dang! So we only got
It means you have to know how to math to do this correctly.
I still don't know.
So, in this one here, remember when we set these things up, we always did the exact same thing. Every single time. We always started by circling our angle, labeling the opposite, find the hypotenuse, which then makes the 10 the adjacent. Okay? What trig function will use adjacents and hypotenuse? Cosine. Once again, ladies and gentlemen, it's right in front of you. Cosine. When your unknown was in the denominator, remember we always did our little exchange-o, Wrote that out yesterday as well. X equals 10 divided by the cosine of 72. Now, in your calculator, you've got a fraction bar. Do you know how to make sure your mode's the right one for trig? Do you know how to change your mode to make sure you're okay? I didn't change mine.
With radius?
Yeah.
Degrees, okay.
Because hers will default.
Oh.
32, 36. All right. Again, buttons shouldn't be all that tough, we hope. Once again, label out what you're looking at, circle your angle, there's your opposite, hypotenuse, and adjacent. What trig function works with adjacents and hypotenuse? Cosine. It's not asking me to figure out what the opposite is, it's just asking me to find the adjacent.
I would even cross off the opposite there. I would just look at those sides and say, I don't have an X, I don't have a number. I'm just going to cross that off, either mentally or physically cross it off on your paper so you know those are the two sides that I have to work with.
Correctamundo. 20.35. $13. No, I think we're just reviewing now, but. So now we have to find an angle. We still do the exact same thing. We circle, label, opposite, hypotenuse, and adjacent. Well, I know my adjacent, I know my opposite. What trig function is opposites and adjacents? Tangent. Which means I have the tangent of something will equal 12 over 15. Now, when you're trying to find the tangent, that's when you have to use the inverse button. Okay? This is when you use your inverse button. Your angle will equal the inverse tangent of 12 over 15. Second tangent 3866. Okay. When you're searching for an angle is when you hit the inverse button. That's the only time you hit the inverse button. Josh, don't do that to share. Thank you. The only time you hit the inverse button. Okay? What trig function are we going to use now? Sine. Very good. Remember a circle. $16.6. Oh, I skipped 14, didn't I? Yeah. The smartboard stuff? Oh yeah, yeah. We had pretty sure this was pretty expensive. Pretty expensive. The smartboard and all the materials to make everything work. Oh really? Oh, that's cool. Yeah. Oh, that's cool. I haven't seen that one. No, I haven't seen that one. It's another sign. Why doesn't that surprise me? Yeah, don't do that again. Okay, please. $49.88. Okay. Now, some of the other things that you guys had a tendency of messing up a lot with the trig. Remember we did angles of elevation, angles of depression. Yeah. We did stuff like this. These types of problems are also very common. You got to remember what parts go where. That's about it. I mean, it wasn't very tough, but it's been a while. And these are very common problems also that you throw in finals because they're not tough. This was coming from that Chapter 8 test. So it's not on here. Going back to your old stuff, rewriting things down. So what we got here, you've got from a point 196 feet from the base of a redwood tree. The angle of elevation to the top of the tree is 74.3 degrees. Find the height of the tree to the nearest foot. Well, angle of elevation, if you recall, was line of sight looking up. Line of sight is your eye value looking up to an object. Now, if it's telling you that you are 196 feet from the base of something, that's horizontal distance. You've got the tree looking up, and you're coming down this way. Now, they're trying to ask, this is 74.3. They're trying to figure out how tall is the tree. What trig function are you going to use here to figure out the height of the tree? Tangent, very good. Because you've got an opposite and you have an adjacent. So you use tangent here to set this up. Oops. So we know that the tangent, 74.3, is x over 196. Multiply over. Press a bunch of buttons. 196 tangent 74.3. And it said round to the nearest foot. So what would you do? Nearest foot. $697. Okay.
Guys, just remember, anything in or on the ground, that's where you're writing the articles.
This was one where you had to do two parts to it.